Hi, I'm Jayapratap. I'm going to solve question 6 of 6 in midsem exam. So the differential equation given is y double dash plus 16y is equal to 4 direct delta function of t minus 3 pi. So the first A is what kind of real life phenomena is captured by the direct delta function. So direct delta function actually only gives two values, that is infinity when t is equal to a and 0 when t is not equal to a. So as soon as t gets equal to a, it gives a spike in the graph. So it shows a sudden impulse or sudden increase in the force or the movement or any quantity which we are calculating. So here in the spring mass system, when t reaches 3 pi, so it gets a sudden impulse, it is hit by a hammer or it is suddenly pulled. So that is the real life phenomena which is being captured by this direct delta function. Then B, without solving and just using your intuition, sketch the graph of the solution. So the impulse is given to the spring mass system at time t is equal to 3 pi. So according to me, at 3 pi, the spring mass system gets a force, gets an impulse, and after that, it has a sinusoidal graph of motion. So now the C part is to solve the differential equation. To solve it, we will use Laplace transformation in both sides. So we get Laplace transformation of y dash plus, as 16 is common, take it out, plus of y is equal to 4 into Laplace of direct delta t minus 3 pi. So there is a formula, Laplace plus transformation of direct delta is e to the power minus sa. So here this term gets converted into 4 e to the power minus 3 pi s, and Laplace of y double dash is equal to s into Laplace of y dash minus y dash of 0, and Laplace of y dash is s into Laplace of y minus y of 0. So substituting the value of y dash here, we get Laplace of y dash is equal to s square Laplace of y minus s y dash 0 minus y of 0. So y dash 0 and y 0 both are given in the question initial condition that it's 0. So we get Laplace of y double dash as s square L Laplace of y. So substituting this and this in the first equation, we get s square Laplace of y plus 16 Laplace of y gives us 4 e to the power minus 3 pi s. So taking Laplace of y in common, we get Laplace of y is equal to 4 e to the power minus 3 pi s by s square plus 16. So y is equal to Laplace inverse of 4e to the power minus 3 pi s by s square plus 16. So by second shifting theorem, Laplace inverse of e to the power minus as into f of s is equal to f of t minus a into u of t minus a. So we will carry on the problem with second shifting theorem. So the f of s function here is 4 by s square plus 16, which is f of equal to Laplace of f of t. So f of t becomes Laplace inverse of 4 by s square plus 16, and also Laplace of sine at is equal to a by a square plus a square. So for sine 4t it would be 4 by s square plus 16. So by comparing we would get f of t as sine 4t. Now substituting this in the second shifting theorem, we would get y as sine of 4t minus 3 pi into u of t minus 3 pi. So until t reaches 3 pi, the graph would be 0, and after t reaches 3 pi it will start a sinusoidal motion. So both these graphs are same,